Welcome to the class, my dear students. The most important and interesting concept in probability and statistics, the most important distribution is the normal distribution. Why I said it is most important means it is each and everything in the nature, whatever you observe, everything is distributed normally. We can see that the percentage of the people who are on an average height is definitely is following the normal distribution. And if you see in the nature, the mean the size of the moon in a month, for example, in the first 15 days, the moon's size will be slowly, gradually it is increasing. By 15th day it will reach to the peak, that means it is full moon, and slowly the next 15 days it will slowly come down, the size come down. So that is what you can say in the nature, everything is normally distributed, we can say. For another example, suppose if you just observe the height of the people, actually in a country, if you see the height of the people, most of them will be covered in this region. That means most of them will be, that means there will be a very less percentage of people who are having who are of less height, and at the same time with the more height also. So this particular in these two regions it is less, whereas on the average, that means it is called as average, that means mu, the height of the people is lying around this mu, that means around the mean. This is what the portion generally. So we generally say that whenever any in naturally, whenever whatever you are considering in the nature, everything is being distributed normally. So now here there are some characteristics of the normal distribution. The first thing is it is symmetric about the mean. So as I said, on an average, we consider that is called as mu. And for this, about this mean, totally the curve, the normal distribution curve is symmetric. That means half after the, that means on the right hand side of the mean, half of the portion is covered. On the left hand side of the mean also half of the portion is covered. So we say that it is the symmetric about the mean. And coming to the unimodal, what do you mean by the unimodal? Unimodal means there is only one peak at a particular point. The peak value is a unique point at which it is the peak. That means, on as I told you, in the first 15 days, 15th day of the month, the full size of the moon is been appeared, right? So that is what the peak, and that peak is only one biggest peak will be there, and that is called as the unimodal. And coming to the mean, median and mode, all of them are equal, and they are all located at the center of the distribution. And now the curve is continuous. What do you mean by continuous curve? There are no breaks or there are no holes in this curve. You can see that the size of the moon, as I told you, slowly increasing and increasing, and after 15th day slowly decreasing and decreasing and decreasing. So what do you mean by that? The curve is totally continuous, and there is no break or there is no holes between the any particular point of the curve, and that is what meant by continuous. And if you observe that the curve never touches the x-axis, never, it goes on to infinity, but it never touches the x-axis. That means it never becomes zero. That is what the understanding, that the data never becomes zero. Totally it goes to plus infinity or minus infinity, but it doesn't touches the x-axis. And the total area under this curve is given by 100%. Totally whatever the area we have wanted to consider, this whole area under this curve, that means this much, all this curve is given by, now you can draw the curve like this also actually. So this whole area is given by 100%. Now when I say the whole area is 100%, how much is after the mean? That means on the right hand side of the mean, how much area is covered? This is 50%, and on the left hand side of the mean is also covered as 50% because it is symmetric about the mean. You can also say that if it is 100% it is okay. If you call this as 1 totally, then it is 0.5, and this is also 0.5. On the left of mu is 0.5, on the right of mu is also 0.5. This is what you can understand about the normal curve. And also this is called as bell shaped curve, they call it as, or we can also call this as the Gaussian curve. Is called as the Gaussian curve. So on the scientist name Gauss, and the notation for this is x is equal to n of the normal distribution. N stands for mu is the population, sigma is the standard deviation. So this is what the notation. Let us now go a deep dive on this normal distribution. Try to understand the concept of what is the probability density function. Now, when I discuss about the probability density function, you always we have to think about the other distributions. Whatever you have probability density functions for, you have binomial theorem, binomial distribution. For the Poisson, what is that? And for exponential, what is the probability density function? All these you have to compare, then only you will remember the probability density function. And coming to the standard normal distribution, now what is the purpose of the standard normal distribution? First I will teach you, and then I will come to this particular topic. Let us now see that the total curve under the total area under the curve has been divided into this particular pattern. This is also called as 68, 95, 99.7 rule. That means what actually? Suppose for the given data, the average of the data, that means that mean is always located at the center of the curve. Okay, that is called as mu. Now, the mu plus sigma and mu minus sigma, that means plus or minus 1 sigma, if you take the area of the curve under the curve in between plus or minus sigma is how much? 68%. 68% of the data is covered in this region as mu plus or minus 1 sigma. And mu plus or minus, this we have done already in the previous lectures also. Now I am going to explain about this because we came to the normal distribution now. So mu plus or minus 2 sigma if you take, then see the wide range of the wide range is there, no? So this is the data, 95% of the data will be occupied between plus or minus 2 sigma. And then 99 points, see the wideness of the curve, the width of the curve is being increased, correct? And the width of the area is being increased under the curve. And plus or minus 3 sigma, 99.7% of the data is being occupied. The area is 99.7 if it is plus or minus 3 sigma. If it is plus or minus 2 sigma, it is 95%. Plus or minus 1 sigma, it is 68%. So let us now understand this by using one more example. For example, now this is the normal curve. Now let us say the mean of this curve is, at example, let us say some x is equal, the mu is equal to 70, let us say. Mu is equal to mu is equal to 70, let us say. That is equal to mu, okay. Now, if I say that the mean is mu is 70 and sigma is equal to 10, if I give sigma is equal to 10, what is meant by that? When sigma is equal to 10, then this value will be 70 plus 10, which is 80, and then plus 10, 90, plus 10, 100, plus 10, 110, like that it goes on. And here it is minus 10, 60, minus 10, 50, minus 10, 40, minus 10, 30, like that it goes on. Now, suppose I wanted the region, the area under the region between 70 to, let us say, 70 to 90. Now, this is what we need. What is the area of the region under the curve between 70 to 90? So, to find out that particular area under the curve, between 70 to 90. What is this area actually? This is what the area, correct? Between 70 to 90 is this area. So how to find out this area now is the question. How much is the area? Now as I have explained you that the total area below mu is 0.5 or 50% and above mu under the curve is again 0.5. That means 0.5, that means 50%. Okay, so 50% of the curve is on the right hand side of mu, 50% of the curve is on the of the area is covered on the left hand side of the mean. Okay, so now we wanted to find out the area, how much is area being occupied between 70 and 90 to find out this one. Now look at this question. What I told you is 70 and 90. 90 means what? It is sigma is 10 as I told. So 90, can we equate this 90 as 70 plus 2 sigma? Correct? It is 2 sigmas is 70 plus 2 sigma. And what is 70 minus 2 sigma? 70 minus 2 sigma is 50. That is 70 minus 2 sigma. So now what I mean to say here is, what is the area which is being covered between mu plus or minus 2 sigma? If I ask you, this is mu plus or minus 2 sigma. We have just now done that. Mu plus or minus 2 sigma, there is, the data is covered 95%. So now what is this total area is 95%, correct? So this total is 95%, but we don't want the total, correct? We want only half of this, because it is here 20, here 20 it is. So only half of this. So what is this area? 95 by 2. 95% by 2, which is equal to 47.5 of the area. What do you say about 47.5 means? Let us say it as 0.475. You can write like that, correct, in the in this way. So when I say 0.475, this is what the area covered in this region, which is what, below 95% means the total area is covered as 95%, but we don't want this portion, which is this. We wanted only between 70 and 90. So that is given by 0.475. So now let us see this same concept if I wanted to change in a different way. That means I write this mu as 0. Let us now write down that mu is equal to 0. When I want to change this total scale, because calculation for this like this is a bit difficult. So to make this calculation as in an easier manner, the scientists have introduced another distribution which is called as the standard normal distribution. So to make this as in a easy way, and for taking less time, you can solve the problem. By taking less time, you can solve the problem. So for that purpose, the standard normal distribution has been invented by the statisticians. Now what is this? Let us say, always we change the scale for in the standard normal distribution as mu is equal to 0 always, and we make that sigma is always equal to 1 in the standard normal distribution. Now if I ask you, what is the mu in the original normal distribution and what is mu in the standard normal distribution, means like this, you have to draw the figure and understand now. What is mu? Where mu is located? Always mu is located at the center of the curve, right? At the center of the curve, always mu is located. And now I am telling that this has been scaled as mu is equal to 0 and my sigma is equal to 1. So that means what? When you say sigma is equal to 1, that is 1 and then 2 and then 3 and then 4 and then 5 and so on. And here it is negative 1, negative 2, negative 3, negative 4 and so on. Like that, because sigma is equal to 1. Now I wanted that region between 70 and 90. So for this, there is a small calculation to make this into the standard normal distribution as z is equal to x minus mu over sigma. If this is the notation for the standard normal distribution, when I want x is 70, that means I want to get 0, correct? When x is 70, 70 minus mu is also 70 over sigma is 10. So it is the value 0. So when I say, because the mean is 70 here, when I change it into the standard normal distribution, the mean mu must be equal to 0. How you will get mu as 0? By using this formula. Clear? Now, I wanted the region between x equal to 70 to 90. So, the corresponding value of z value is 0 when x is 70, and when x is 90, the value becomes, the z value becomes 90 minus 70 by 10, which is equal to 20 by 10, that is equal to 2. So the z value, the corresponding z value is 2, and so the line is this. The same thing you have done here also, as when x is 90 and when z is 2 is this in the standard normal distribution, and the curve between the area of the curve occupied below the curve, and below the curve is given by, above the x-axis is given by this region, and this is what the same thing we get. Now my point is now to tell you that here the area between 0 and 2 you need to find out. So it is nothing but the probability of 0 less than z less than 2. So to find out this probability of z lying between 0 and 2, we have to use the standard normal table which is available for us, which is very handy for us. Instead of doing this much calculation, instead of doing this, if you know the value of the corresponding value of z, then our job will be very much easier. So what is that? Now I'm going to tell you. This is called as the standard normal distribution, okay, table. Now I wanted to see that the area which is being covered between 0 and 2. So between 0 and 2 means you have to take for 2 value. That means here in the table, what is when the in the vertical line there are 0, 0 0.1, 0 0.2 on this. I'm sorry. And then it is 0, 0 0.01, 0 0.02 and so on like this. Okay, so now what we are going to do here is in all these points you can see for point 1, 2 you want to find out, means corresponding row value, corresponding column value, what is the common point, that is what the area. Okay, the points which are here given are the area. So now if I wanted to see what is the area for of z for less than 0.11, means you have to see 0.1 and here 0.01, that is giving you 0.11. While doing the problems in future in this lecture, I will make you to understand. Now the value of 2 is what? From 0 to 2 as I said. So less than 2 value is given by 0.4772. So see the column, the corresponding column here is 2. So we wanted to say only at 2, right? So it is 0.4772. Now try to understand here what we have got here is also, it is 0.4772 is the area which is being covered under the curve by using the standard normal distribution. Now here you are able to understand that just by using the normal calculation it is 0.475. By using the standardization, by using the standard normal distribution and the standard normal table, you got the nearly same value, which is 0.4772. I hope you could understand what is the purpose of standard normal distribution. Now let us come to the problem. This is why we have given this as z is equal to x minus mu over sigma. The standard normal distribution is also called as the z distribution, we call this as. Yes, we call this as the z distribution. Yes, with that, this is what about the link between the normal distribution and the standard normal distribution. I hope you could understand. In the next video, in the next lecture, I am going to explain some of the problems to make you to understand what is the, by using the standard normal distribution, how to calculate the area under the normal curve. Thank you so much.